Custom labels solve a problem that seems small until it isn't. Every Salesforce org has text that lives in code, error messages, button labels, URLs, and every time someone needs to change that text, a developer gets pulled in. A deployment gets scheduled. A release window gets consumed. By the end of this tutorial, you'll know exactly how to use custom labels to move that text out of code and into a place admins can update themselves instantly, without anyone touching a deployment. The reason custom labels exist is simple. Code and configuration change at different speeds. A developer writes an error message today. 6 months later, the legal team wants different wording. Without custom labels, that's a code change, a PR, a review, a release. With custom labels, that's a 2-minute setup update. The platform was designed to separate things that change rarely, code logic, from things that change often, user-facing text. Custom labels are the mechanism for that separation. The hidden cost of hard-coded strings shows up at scale. Imagine 50 Apex classes, each containing their own error messages. When one message needs to change, maybe a product was renamed or legal updated consent copy, someone has to grep the entire codebase, find every occurrence, update each one, test it, and deploy. Now imagine that same change taking 30 seconds in setup. That's the difference. Hard-coded strings are technical debt that charges interest every time text needs to change. A custom label is fundamentally a key-value pair. The key is a developer-defined API name, something like error_account name required. The value is the string it resolves to, something like account name is required. The value can be up to 1,000 characters, so it handles full sentences, paragraph summaries, and even short URLs comfortably. The name is permanent once created. You cannot rename it, so choose clearly. Think of it like a variable name in your code. It needs to be readable 6 months after you wrote it. Custom labels live in setup under the Custom Labels section. This is important because it means an admin, not a developer, can open this page, find the label by name or category, and change the value. The change takes effect immediately. There is no deployment, no code review, no release window. The next time any code, component, or flow reads that label, it gets the new value. This is the entire point. Text that might need to change lives in a place where the person who needs to change it actually has access. In Apex, the syntax to read a custom label is system, label.yourLabelName. The system namespace qualifier is optional. Label.yourLabelName also works, but including it makes it immediately obvious what you're referencing when someone reads the code later. The return type is a plain string, which means you can use it anywhere a string is valid, as an argument to or a handled exception, in a string.format. Call, in a log message, concatenated into a larger string. There is no special method or cast needed. Here's how this looks in practice. Imagine a validation service class that checks an account record before saving. Instead of writing throw new or a handled exception, account name is required. Directly in the class, you write throw new or a handled exception, system, label.error_account name required. The label holds the text. The class holds the logic. Now when an admin needs to change the wording, say, from account name is required, to please enter a name for this account. They update it in setup. The code doesn't change. No deployment. The new wording is live immediately. Testing code that uses custom labels requires no special setup. In your test class, you reference the label exactly the same way you do in production code. System, label.error_account name required. Salesforce reads the label value directly in test context. It doesn't count against your SOQL governor limits, and you don't need to mock it or inject it. If you want your test to assert the correct message was thrown, compare against the label reference, not a hard-coded string literal, so the test stays valid even if the label value changes. In a Lightning Web Component, you import a custom label as a static import at the top of your JavaScript file. The syntax looks like this. Import label_name from at Salesforce/label/c. your_label_name. The C is your namespace. For most orgs, it's the default namespace, so it stays as C. For managed packages with a custom namespace, replace C with your prefix. Each label needs its own import line. The imported value is a plain string that resolves at runtime to the correct language for the current user if translations are configured. To use a label in your LWC template, you assign the imported constant to a class property. The standard pattern is to group all your labels into a single object property, something like labels equals edit account title, label_edit_title, save button, label_save. and then reference them in the HTML template as labels, edit account title, and labels.save button. This keeps your template clean and makes it obvious which strings come from labels versus which are computed values. The HTML never contains hard-coded user-facing text. When you need a label's value inside your JavaScript logic, not in the template, you don't need to assign it to a class property at all. The imported constant is directly usable in your method. For example, if you're validating that a name field isn't blank before calling an Apex method, you can write this to error message equals label _ acquired directly inside the handler function. The imported constant holds the string. You use it like any other variable. This is simpler than the template pattern because there's no binding layer in between. In flows, the syntax for a custom label uses what Salesforce calls a merge field. The format is $label.c.your_label_name. The $label is a global variable that Salesforce provides in the flow editor. You can use this merge field in screen components, inside display text elements, input labels, and help text, and also in decision element conditions, assignment elements, and fault path error messages. If translations exist for the label, the running user sees their language automatically, with no conditional branching required in the flow itself. The Translation Workbench is what makes custom labels genuinely multilingual. You enable it once at Setup Translation Workbench Enable. Then for each language your org supports, you navigate to Translate, select Custom Label as the component type, choose your target language, and enter the translated value for each label. At runtime, Salesforce checks the running user's language, looks for a matching translation, and returns it if found. If no translation exists, it falls back to the org's default language, then to the label's base value. Your Apex, LWC, and flow code references the same label name in all cases. The platform handles the language routing entirely. The protected component checkbox on a custom label only matters if you're building a managed package for AppExchange distribution. When protected is checked, the label is only accessible from code inside the same package namespace. If a subscriber org tries to reference it from their own Apex or LWC, they get a compile error. The purpose is to prevent subscribers from building dependencies on internal labels you might rename or remove. For standard single org development, which is most Salesforce work, leave this unchecked. It has no effect outside of managed package scenarios. One mistake that breaks in translation: splitting a sentence across multiple labels and concatenating them. It seems logical in English. Combine label_greeting, hello, with a username and label_suffix. Your session has expired. But word order varies across languages. The same sentence structure in German might put the verb at the end, and a direct concatenation of the same parts in a different order produces grammatically wrong output. The rule is one complete, user-facing message per label. Never split a sentence. If the message includes a dynamic value, use string.format with a single label that contains the placeholder. In a Salesforce DX project, all custom labels live in a single XML file at forceapp/main/default/labels/custom labels.labels meta.xml. Each label is a labels block containing the API name, language, protected flag, short description, and value. You deploy with SF project deploy start and retrieve with SF project retrieve start, custom label. Because all labels share one file, you'll see all of them in every diff when any single label changes. This is normal. Manage label sprawl by using clear naming conventions and the short description field, which appears in the setup list and helps you find labels without opening the file. Start by establishing your naming convention before you create any labels. The API name is permanent. Once created, it cannot be renamed. Use a category prefix that encodes what the label is for. Error_ for exception messages, UI_ for visible interface strings, URL_ for external links, and config_ for operational settings like retry counts or batch sizes. This takes 30 seconds per label and makes the setup list self-explanatory to anyone who didn't write the original code. A label named error_account name required is unambiguous. A label named message1 is a maintenance problem. The payoff from centralizing user-facing strings is most visible when something needs to change org-wide. One setup update propagates everywhere simultaneously. Every Apex class, every LWC, every flow that references the label picks up the new value immediately. No search and replace. No risk of missing an instance somewhere. No deployment. For large orgs where a product name, a regulatory disclosure, or a help URL changes periodically. This is a significant reduction in low-value developer work. The measurable outcome: text changes that previously required a release now complete in under 5 minutes. The boundary rule is the clearest summary of when to use custom labels. If a string sits at the edge between code and configuration, something a developer writes today that an ops team or admin might need to adjust later, it belongs in a custom label. Error messages, UI strings, configurable URLs, environment-specific flags. What doesn't belong? Secrets, API keys, OAuth tokens, passwords, client secrets. Anything you would not want readable by any Salesforce admin who has access to setup. For those, use named credentials or custom settings with field-level security. Get both rules right, and custom labels become straightforward to use without surprises. That's the complete picture of custom labels: what they are, how to access them from every part of the platform, how translations work, how the metadata deploys, and where the limits are. The full written tutorial at Real Syllabus covers every code example shown here: the Apex validation service, the complete LWC component with HTML and JavaScript, the flow merge field patterns, and the metadata XML structure, with explanations you can reference while you build. Find it at realsyllabus.com.